Hi there, welcome to this video on polar functions. We're going to talk about distance from the origin in this video as well as a rate of change of polar functions. So, jumping into it, you'll be successful in this lesson if you can evaluate a polar function knowing your sine and cosine values of unit circle angles. If you can determine whether a polar function's distance to the origin is increasing or decreasing, and you can determine whether a polar function has a relative extrema on an interval, as well as, we're missing one, you can determine average rate of change. So, remember, a polar function is defined as radius is equal to f of theta, where the inputs are angle measures that we plug in. Most of the time, we generally are selective and we pick specific values of theta to plug in. We're going to pick quadrantals as well as angles that return nice, outputs. Kind of like, so if it's a sine function, we're going to choose pi 6 because it gives us an output of 1/2. And if it's cosine, I'm going to choose pi thirds because that cosine of pi thirds is 1/2. Okay. Let's go ahead and talk about our first topic here, which is distance to the pole. When we say that the distance to the pole or to the origin is increasing, we mean that the function values are moving away from the origin, either the positive or negative direction as theta increases. When we say that the distance to the origin or the pole is decreasing, we mean that the function values are moving toward the pole in either positive or negative directions as theta increases, okay? And I want to go ahead and show you this visually. Here's a grapher, and they have this function 2 cosine of 2 theta, and you can see this little dot here, and this is going to plot our point as we go ahead and change our angle theta. So notice as I slide this, notice that dot is getting closer and closer to the origin here, okay? And so you can see that our radius is a positive 2, but as I get closer and closer, as I increase my theta, that radius is going towards 0. So their distance would be decreasing from the pole, okay? But watch this. Here, as I continue my increasing my angle theta, notice that it is going away from the origin. My radius is negative, and it's getting more and more negative, okay? So here's the main idea. Are you going away from 0 or towards 0? If you're going towards 0, distance is decreasing, like right now. If you're going away from 0, distance is increasing. So one way in order to determine whether the function is increasing or decreasing on a particular interval is to create a table of values to identify what is happening to the radius. A way to remember this is if the signs match, the distance to the pole is increasing. The function is positive and increasing or negative and decreasing. If the signs are opposite, then the distance to the pole is decreasing. If our radius values are positive, but they are decreasing, or if they're negative and they're increasing, okay? So let's go ahead and look at an example. Here we have the polar function r equals f of theta, where f of theta is equal to 1 plus 2 sine theta in the polar coordinate system 0 to 2 pi. For each interval, determine whether the distance between the point f of theta, comma theta, and the origin is increasing or decreasing, and explain your reasoning. So what I like to do here on these problems is make a table again, and I'm going to go ahead and find some values. So this is 1 plus 2 sine theta. Again, what I'm going to choose are my quadrantals, so 0 and pi halves, because that's what my domain is. And then I'm going to choose, since it's sine, I'm going to choose pi 6 also, just to get another point in here. So now I can compute. 1 plus 2 times sine of 0 is 0, so this gives me 1. 1 plus 2 times sine of pi 6 is 1/2, so that gives me 2. And pi halves, 1 plus 2 times sine of pi halves gives me 1. So we get 3. Okay, so is our distance increasing or decreasing from the pole? Well, look at our radius. What's happening to our radius here? 1, 2, 3. Our distance is increasing. The distance is increasing. Because the radius is positive, and increasing. Okay, well, how about on a different interval? What if I looked now on pi halves to pi? Again, I have my quadrantal angles that are given in my restricted domain, but what I'm going to choose is another angle. Again, since it's a sine function, I'm going to choose a pi 6 angle in this quadrant, which would be 5 pi over 6. Okay, so again, radius here is 1 plus 2 sine theta, and we already know this first value. We know that that's 3. At 5 pi over 6, we have 1 plus 2 times sine of 5 pi over 6 is still positive. So here it's 2, and then at pi, 1 plus 2 sine of pi is 0, so we get 1. So now it's 3, 2, 1. So again, our radius is positive, but what's happening to these values? They're decreasing. So our distance to the pole is decreasing. Why? Because the radius is positive and decreasing. Okay, so that's pretty much it. Okay, here is a couple of practice problems. I would like you to go ahead and please pause the video. Consider the graph of the polar function f of theta equals 1 minus 4 sine theta in the polar coordinate system for 0 to 2 pi. Which of the following statements is true about the distance between the point with polar coordinates f of theta, comma theta, and the origin? Is the distance increasing? Is it decreasing? And why? F of theta is positive and increasing on the interval. F of theta is positive and decreasing. F of theta is negative and decreasing. F of theta is negative and increasing. Okay, pause the video. Go ahead, try this one, and we'll show you the results here. Okay, hopefully you got D for this answer. The distance is decreasing. If you choose the angles just on the domain, pi halves and then 5 pi 6, and you plug these in, you can see that you start at a radius of -3, and then you end at a radius of -1. So our radius, f of theta, is negative, and it's increasing. It's getting more and more positive, closer to 0. Okay, so distance is decreasing to the pole. Here is another practice problem. Consider the graph of the polar function f of theta equals 1 minus 2 cosine theta. As theta varies from pi halves to 3 pi halves, how is the distance between the origin and the point with the polar coordinates f of theta, comma theta changing? Make sure, there's a big span here, so make sure you plug in multiple angles. That's my hint, okay? All right, try this one. I'll pause the video, and I'll show you the results here in a second. All right, the answer again is D. The distance increases and then decreases from pi halves to 3 pi halves. So if you went ahead and you plugged in your quadrantals, pi halves, pi, and then 3 pi halves, you could see that we go from 1 to 3 back to 1. I threw in the pi thirds again because it is a cosine theta function. So that gives me a kind of a better picture, okay? So make sure you do the, multiple angles so you can get a clear picture of how that radius is changing. All right, next topic. We're going to go ahead and talk about extrema. If a polar function changes from increasing to decreasing or decreasing to increasing on an interval, then the polar function has what we call a relative extremum on the interval. A relative extrema corresponds to a point farthest from the origin or closest to the origin on a given interval. The distance to the origin is the absolute value of the radius r, okay? So here is a graph of the polar function r of theta equals 3 minus 2 sine theta. And the function has two relative extrema. The one that's closest to the origin is right here at 1. Okay, so that distance is 1, right? A radius of 1. But then I also have this distance all the way down here. The furthest point, right, is 5, 3 pi halves. So that one has a distance of 5 to the pole. So both of those are considered relative extremum. Okay, so let's go ahead and look at some examples here. They say, consider the graph of the polar function r equals f of theta, where f of theta equals 3 cosine of 2 theta in the polar coordinate system. On the interval 0 to 2 pi, which of the following is true about the graph of r equals f of theta? And so what they say here is, for the input values pi force and 3 pi force, the function r equals f of theta has extrema that correspond to the points that are farthest from the origin. For the input values, theta equals pi fourths and 3 pi fourths, the function r has extrema. However, the only point corresponding to the point farthest from the origin is pi fourths. And then here we have pi halves and pi. Same idea. So kind of what we want to go ahead and do here is we want to create, again, a table of values. So I'm going to make theta, and I'm going to plug in here 3 cosine of 2 times theta. And what I'm going to do is I'm going to take all my quadrantals. I guess I take my quadrantals here, so those are easy enough, right? 0, pi halves, pi, and just because I know that this one's going to require a good amount, 2 theta. Okay, we have 3 pi halves, and then I guess 2 pi. So I'll quickly do these just because these kind of help. And then 2 C and D, this might give me an idea. If I plug in 0 here, we get 3 times cosine of 0, which is 3 cosine of pi halves. So be careful here with this. Notice that I'm doubling this. So this becomes 3 cosine of pi, which is a -1. So here we get -3. Okay, and then at pi, this is 2 pi, so I'm back cosine of 2 times pi, which again gives me 3. So it looks like these would be extrema points. If I go ahead and do this, this is 3 pi, 3 cosine, right? 2 times 3 pi over 2. These are going to cancel. And so again, we get -3, and then 2 pi is also going to be 3. So they also reference the pi fourths. Now I know this is a cosine function, so pi fourths normally might give you a weird number, but it's being multiplied by 2. So what happens is it doubles that value, right? So 2 times pi over 4. So really this ends up being a quadrantal value, right? You get 2 pi fourths, which is pi over 2. So anyway, this gives you 0. This gives you 0. And if my thoughts are kind of right here, I think all of these might end up doing that. So we get 2 times 3 pi over 4. Okay, again, this is 3 pi halves, which is 0. So we get 0. So all these pi fourths angles are going to end up giving us 0. We can do the same thing here, but again, that would give us 0. So it looks like our extrema are going to be pi halves and pi. So let's see, what's the difference between these two? For the input values, theta equals pi halves and pi. The function r has extrema. However, the only point corresponding to theta equals pi is farthest from the origin. Well, the other one was the same distance. It was just negative. So D, for the input values, theta equals pi halves, theta equals pi. The function has extrema that correspond to the points that are farthest from origin. Yep, D. All the answers D in this lesson. I think they are. They might be. I don't know. Okay. All right. Here's a practice problem. Go ahead, pause the video. I want you guys to go ahead and try this one. This one gives a table, which is kind of nice. The table gives all of the relative extrema. Oh, so you can see the extrema here. For all input values theta in the domain of the polar function. Which of the following statements is true about r equals f of theta in the polar coordinate system? Pause me. Go ahead, try this one, and we'll talk about it. Okay, no surprise here. The answer is D. This should be pretty easy. They say the greatest distance is 4, and that's because it is the biggest value. Although I know it's negative, right? I know it's negative, but still it's the biggest value away from the origin. So it's the absolute value of all the extrema. Okay, so answer there is D. Let's move on to average rate of change. For a polar function, the average rate of change over an interval theta 1 to theta 2 is our average rate of change formula. The radius based upon theta 2 minus the radius evaluated at theta 1 over theta 2 minus theta 1. So again, it's outputs divided by inputs. So pretty straightforward. Here's our first example. In the polar coordinate system, the graph of the polar functions r equals f of theta is shown for the domain of theta for 0 to 2 pi. On this interval of theta, the graph has no holes, passes through each point exactly once, and as theta increases, the graph passes through the points labeled A, B, C, and D in that order. What is the average rate of change of R with respect from B to C? So again, I want average rate of change, and that is going to be the radius of theta 2 minus the radius at theta 1. Oh my gosh. Theta 1 over theta 2 minus theta 1. So here they say from B to C. So we need these points. So if we go ahead and we look at B, it looks like B is, what is this? Pi thirds. Sorry, radius goes first. Pi thirds and a radius of 4. And then C, it looks like it has a radius 1 and an angle of pi. Okay, so this should be pretty easy. We're going to go ahead and plug in our radius, 1 minus 4, right? And that makes sense because we decreased, right? Our radius was 4, and now we're at 1. Okay, over pi minus pi thirds. So we get negative 3 over 2 pi thirds. Okay, and we can go ahead and keep change flip over 2 pi. So we end up getting negative 9 over 2 pi. Okay, answer is going to be C, right? So remember, outputs, which is your radius, divided by the inputs. Okay. All right, here's a practice problem for you, and that'll do it for this lesson. Please pause the video. Here they want you to go ahead and do the same thing. They want you to calculate the average rate of change with respect to theta from A to B. So go ahead, try that one. I'll show you the results here in a second. Okay, hopefully you got B, negative 3 over pi. Point A is angle 0 with a radius of 5. B is angle pi thirds with a radius of 4. So once we have those points, we go ahead and again, radius divided by your angle. So 4 minus 5 gives us negative 1, divided by pi thirds minus 0, which gives us pi thirds. Keep change flip, and you get negative 3 over pi. That's going to do it for this video. In this video, we went ahead and talked about a distance from the origin and how to determine if a polar function is increasing its distance from the origin or decreasing. We also talked about extrema of polar functions, just the biggest and closest point to the origin, as well as the average rate of change of the origin. If you learned anything, give this video a thumbs up. I'll see you in the next video.